So this video is about summation notation. And there's a symbol that roughly looks like this, crudely anyway, and it's a Greek symbol for S, sigma. And so when you hear the word sigma notation, that's just a notation that is symbolized with this symbol right here. And all it is, there's a lot of parts to it, but basically it's a lot easier than it looks. And so their parts are the formula part, which goes right here, and you might have something that looks like this, and a lower bound and an upper bound for how many terms you have. And so what this is a shorthand. It means there are a first term, a second term, and a third term. You're going to add those together. And as you might guess, you would plug these terms, first term, second term, third term, into this formula. So this would be 2 times 1 plus 1, and this would be 2 times 2 plus 1, and this would be 2 times 3 plus 1. Notice the only part that changes is this part, which is how many terms you have, first term, second term, third term, and you would just go all the way until you reach your upper bound. So you could do this by hand, add this and this and this together, and you would get an answer for that. But that's the long way to do it. That's a way to do it, but you wouldn't want to do that every time. There's some formulas we can use to make this a lot shorter. See, because if this is like 307, then we'd be in trouble doing it the long way. So I'm going to write down some formulas. Okay, so here are two very basic formulas right here. The sum of some number, which would be like, if this was just a 2 here, every single item would be a 2 and a 2 and a 2 and a 2 and a 2, and so you'd just be adding up a whole bunch of the same thing, which is multiplication. So you would just do whatever number that is times however many you have. So that's the formula for that. Sometimes you just only have a letter here. So maybe if I said, in this case, the sum, and if this formula was just an x, then the formula would be x times x plus 1 over 2, except you have to figure out what is up here. I should say an n. What is up here? So this would be n times n plus 1 over 2. So this would be 307 times 308 all divided by 2, and that's what the sum of this would be. Well, and then there are times when you can put those together. In this case right here, the 2x plus 1. So you can split this up just like with derivatives. You're allowed to split this sum up. So I have the sum of 2x and the sum of 1. And this would be from 1 to 307. And I'm just writing this out the long way just to illustrate all of the steps. But if you're showing this in your work, you probably wouldn't want to show all of these steps. Next, you're allowed to pull this 2 out just like with a derivative. You can put the 2 out here. And then you just have these two formulas, which is what these two formulas are. So this right here breaks down in its simplest parts to these two formulas. Now, you don't have to break it down into these parts. You could just go straight to here. Notice you have this part right here is this part right here. So this would be 307 times 308 over 2. And this one right here is this part. So this would just be the formula, whatever number you have, which in this case is a 1, times the upper bound, which is a 307. And so this summation can be found by using these two formulas, and it is 94,000 863. And this is all just calculator work. So it's a lot simpler to use these formulas. So lastly, here's a large example of you would not want to break these down individually and write out 10 terms, and the first term would be 3 times 1 squared plus 2 times 1 plus 9, and the second term would be 3 times 2 squared plus 2 times 2 plus 9, and the third one, and so on. That would take forever. But you could use these formulas. Here's another formula I wrote in. If your variable is being squared, use this. So for all of these, the answer will be 3 times the y squared formula, which is n times n plus 1 times 2n plus 1 over 6. 2 times 10 plus 1 is 21 all over 6, plus 2 times the y to the first power formula is right here, 10 times 10 plus 1 over 2, plus this one, which fits this formula, a number. So this would be whatever number you have times how many you have. And then you just have to crunch these in your calculator or in your head. You know, you could mark these out. Reduce here. 10 and 2 would reduce. This would be a 5. So, I mean, you could do this in your head or in a calculator. And either way, you'll get 1355. So that's a lot quicker than actually adding all of those up. Lastly, you'll notice that all of these formulas have 1 at the bottom. But if you're presented with a situation like this, and you have a formula here, you want to know how to do this without having to go plug in a 7, plug in an 8, plug in a 9, and so on until you get to 28. We could still take advantage of these formulas. Like, let's say this was a 2x here. Well, you just take the formula that says from 1 to 28, and you would subtract off from 1 to 6. And this formula says plug in a 1, plug in a 2, plug in a 3, plug in a 4, plug in a 5, and 6, and 7, 8, all the way to 28. This one says just a 1, and a 2, and a 3, and a 4, and a 5, and a 6. So if you go all the way to 28 and take away the first 6, then you're left with these. So that's how you do it when the lower bound is not just a 1. And that's all about summation notation.